Our next point is intervals. Our next point is intervals. There are four main types of intervals. There are four main types of intervals. First one is open interval. First one is open interval. The next, second one is closed interval. Second one is closed interval. The next, third one is semi-closed interval. Semi-closed interval. And last one is semi-open interval. Last one is semi-open interval. Semi-open interval. Okay. There are four main types of interval. First one is open interval. Second one is closed interval. Third one is semi-closed interval. Third one is semi-closed interval. And last one is semi-open interval. Last one is semi-open interval. These four types of interval. These four types of interval. Each type we will study bright. First one is, now let us take first interval here. Open interval. First is open interval. First is open interval. Open interval. Open interval. ठीक है, open interval. For open interval, notation what open interval? This notation. Open interval, this. We can represent open interval in that form. In that form, here some first component and there is second component. This notation used for open interval. Here this open interval, here first component and there second component. And in interval, this first component is always less than that of second component. It means first component always strictly less than second component. This open interval. Now let us take definition. Definition what? Let us take definition here. Open interval. First definition, open interval. Here what? Let A, B are the any real numbers. Let A and B are the any real numbers. A, B are any real numbers and A strictly less B. A strictly less B. Okay. Let A, B belongs to the real numbers and A is strictly less than B. Then the set containing X such that this X also belongs to the real number. This X also belongs to the real number and condition not A strictly less X strictly less B. Then this set represent a open interval. This set represent a open interval. What open interval? A B. This set represent a open interval A B. This set represent a open interval A B. Open interval A B. What else? Let A B belongs to the real number and this A is strictly less than B. A is strictly less than B. Then the set containing all those real numbers which are lies between A and B, but A and B are not included in this set. Why not included? Because this is open interval. Here in open interval, these boundary points are not considered. In between या दोघांच्या मधील सर्व पॉइंट या सेट मध्ये येतील, पण हे जे दोन बाउंड्री पॉइंट आहेत ते त्या सेट मध्ये येणार नाहीत. वाय? बिकॉज इट इज ओपन इंटरवल इन टर्म्स ऑफ रियल लाइन. ओपन इंटरवल ऑन रियल लाइन here plus infinity, here minus infinity. If open interval, this suppose here point A, here real number A and here real number this B, then this open interval will be on real line as well. On real line, open interval, all the real numbers lies between A and B. All the real numbers lies between A to B, but A and B are not considered or A and B are not included in this set. Why not included? Because it is open interval. In open interval, boundary points are not included in between this point. Also only those points are included in that set. Okay? This is open interval. For example, if I take open interval, if we take 1 to 5 on real line, 1 to 5 on real line, 1 to 5 set what? Which is equal to set containing, suppose, which is equal to set containing x such that x belongs to the real number, because 1 and 5 are real numbers, such as, and condition what? 1 strictly less, x strictly less 5. It means in that set open interval 1 5, या open interval 1 5 मध्ये कोणते कोणते एलिमेंट्स येतील? all those numbers which are lies between 1 to 5, all those numbers which are lies between 1 to 5, but 1 and 5 are not included in this set, are not included in this set on real line. On real line this set, on real line here plus infinity, here minus infinity, pick up. Then here what? 0, minus 1, minus 2 up to so on. Here 1, 2, 3, 4, 5 and 6. And our open interval what have? 1 to 5. Open interval 1, here 1, here 5. Means in this open interval which one numbers will come? All these real numbers which are start with 1 and end here till up to so on 5. Till up to so on 5, till up to so on 5. But 5 is not considered in that set. Open interval 1 to 5. In this open interval 1 to 5, which one elements are come in that set? All numbers which are lies between 1 to 5, but 1 and 5 are not come in that set. And one more most condition, in any interval first component, this is called first component, that is called second component, and our first component is always strictly less than that second component. It means this. It means this condition is very important. First component is always less than second component. This is what? Open interval. Simple. Open interval. Now next closed interval. Now take next closed interval. Now next closed interval. Closed interval notation what? Closed interval this closed interval. Here first component comma, then here second component. First component is always less than that of second component. Now look at definition. Similarly, let a, b are the any two real numbers. Let a comma b are any two real numbers, and condition what? And a strictly less b. A strictly less b. Okay. Let a and b are any two real numbers and a less than b. Then the set containing x, x also belongs to the real number. Then the set containing all those real numbers which are lies between a less or equal x less or equal b, which are lies between a to b, and in that set a and b are also included because here equal sign, then this set represent closed interval. This set represent closed interval a b. Why? Because here less or equal sign, therefore this set represent a closed interval a b. What? Closed interval a b. Closed interval, it means in that set which one points will come? This a also include, b also include, and all the points lies between a to b, and a and b also include in that set. That's why it is closed interval. On real line, this interval here plus infinity, here minus infinity, this real line. Suppose if you take here point a and here if you take b, then closed interval a to b, then a also included in that set. All the points starting with a till up to so on there. This b also included in that closed set. Here suppose we take x. X means what? All these real numbers lies between a to b, and a and b are also included in that set. This is what? Closed interval. In closed interval, these boundary points are also included. Now suppose for example, if I take closed interval minus 2 to 5, here this first component minus 2 and second component is 5. First condition satisfy होते का? First component is always less than second component. Minus 2 always less than 5. Therefore equal to set containing all those real numbers all those real numbers which are lies between -2 less or equal x less or equal 5. -2 less or equal x less or equal 5 means in that closed interval -2 to 5 कोणता सेट येईल, कोणते रियल नंबर येतील, -2 and -5 हे दोन येतील and all these number which are lies between -2 to 5 on real line this set here on real line here 0 -1 -2 -3 go minus plus infinity here plus infinity here minus infinity here if I take 1 2 3 4 5 6 closed interval -2 to 5 here -2 and here 5 then all these real numbers -2 also include in this set and all these real numbers lies between -2 to 5 and this 5 also included in that set. Why this -2 and 5 include in this set? Because it is a closed interval. Closed that time we also take boundary points and in between its point. This is closed interval. Now next semi-closed interval. Now next point is semi-closed interval. Next point is semi-closed interval. For that same procedure let a comma b belongs to the real numbers and condition a strictly less b this should condition. Now semi-closed interval notation what? Semi-closed interval here first component then comma here second component semi-closed interval. It means first component closed second component open means in that set which one elements will come this first component also come and points which one come first component till up to so on last component but last component will not come in that set because it is semi closed here closed therefore we can take this here open therefore we can't take this element. Okay, now definition set containing all real numbers such that a closed less or equal x strictly less b then this set represent a semi-closed interval closed at a open at b this is what semi-closed interval closed at a open at b a b are any two real numbers and what a is strictly less than b first component is less than that second component then in that set all those real numbers which are lies between a to b and in that set a element is included because it is closed here but b can't included because here open on real line these here plus infinity here minus infinity suppose I take here a real number and this real number here b this here b okay here what have semi-closed interval and these in between real numbers this semi-closed it means a also come in that set and point starting with till up to so on there but b can't why b can't because there it is open and why a is there because it is closed then we should take this point in that set open then we should can't take this point in that set. Here in notebook in our textbook there is one correction note here a belongs to the that semi-closed interval ab but b does not belongs to semi-closed interval ab. This is correction in textbook. What a belongs to that set why because a at closed b does not belongs to this set why because b at open now next last type of interval is fourth one semi-open interval here first component comma then here second component semi-open interval this is semi-open interval. Now similar procedure let a and b are they any two real numbers and a strictly less than b then the set containing okay, then the set containing all those real numbers such that semi-closed a less than x here less or equal b, and it represents a semi-open interval a and closed at b. This is semi-open interval. This is semi-open interval. Okay. Semi-open interval notation is here semi-open and here closed. There first component, here first second component, and first component always is then second component. Okay. Let a comma b belong to the real numbers, are any two real numbers, and a strictly less than b. A strictly less than b, then the set containing all those real numbers which are lies between a to b, also b included in that set, but a can't. That is we call semi-open interval. Here strictness, it means this open. Here less or equal, therefore this closed. Therefore this here closed. Therefore this here closed. Now on real line, here what? Plus infinity, here what? Minus infinity. If I take here point A, here take B, but this what have less or equal, it means B included in that set. B included in that set, and here A strictness, X is strictly greater than A. X is strictly greater than A. It means A not included. A why not included? Because here strict, and X less or equal B. X less or equal B. Here B less or equal म्हणजेच B पेक्षा सर्व लहान पॉइंट्स, and X strictly greater A म्हणजेच काय A पासूनचे पुढचे सर्व पॉइंट्स. This means A can't included in that set. This what? Semi-open interval. Semi-open interval AB. Semi-open interval AB. Now just we see the intervals and types of intervals. There are four main types of intervals. First one is closed interval. Second one is open interval. Third one is semi-closed interval. And last semi-open interval. Here most important condition in these four intervals is that this is called first component and this is called second component. In interval, first component is always less than second component. First component is always less than second component. That is A strictly less than B. Now closed interval set containing here A and B are any real numbers. Let A, B belongs to the real number. Therefore, closed interval AB, what? All these real numbers which are lies between here A less or equal X less or equal B. A less or equal X less or equal B. Why? Because here closed interval. Now next open interval AB, set containing all those real numbers such that which are A less X less B. Here open interval, that's why their strictness sign. Here closed interval, that's why their less or equal sign. Their equal sign. Here less sign. The next semi-closed interval. All those real numbers which are lies between A less or equal X and here open, that's why here strictly less than B. X greater or equal X and X strictly less than B. Last one is semi-open interval. Set containing all those real numbers such that A here open, that's why less than X, and here B is closer, therefore here sign less or equal B. These are the four intervals. First one is closed, open, semi-closed, semi-open. Closed, it means we take these boundary points. Open, then you can't take this boundary point, we only take in between this point in that set. Then next semi-closed, therefore we include this point in that set. Open, but we open at B, we can't include B in that set. Here open at A, therefore we can't include A in that set, we only include B and in between A and B points. Now our next point, now let us see number of elements of a set. Suppose now next point, what number of elements of a set, or त्याला आपण म्हणू शकतो cardinality. ठीक आहे. फॉर एक्झाम्पल इफ आय टेक हियर लेट A equal to set containing suppose I take x y z. It is a set. Why it is a set? Because all the alphabets, we know that all the alphabets are well defined, therefore it represents a set. Now here A represents a set. Now small x, small y, small z are the what elements of a set A. X, y, z are the elements of a set A. Now here what you want, we have to find the cardinality of that set, or the number of elements of that set. Number of elements, how many number of elements in that set? 1 2 3, 3 elements. Therefore we say that n of A, number of elements of a set A, which is equal to what? 3. Right? Number of elements of a set A are 3. Why 3? Because 1 2 3, or that also we say that cardinality of A. Same, number of element of a set A which is equal to 3, or cardinality of a set A which is equal to 3, means just count number of elements in that set. Now another example, suppose I take next set B. Suppose I take B equal to set containing, if I take 1 2 1, then 3 4, then what is the cardinality of the set B, or what is the number of elements of a set B? Number of elements n of B, or cardinality of a set B. Number of elements in that set, how many number of elements? 3 or 4? 3, is it right? Or 4, is it right? 3 right answer. Why? Because in that set there are 3 elements. Why? 1, these 2, these 3, these 4, means here 1 2 3 4, here 4 number of elements. How many number of elements? 4. But here these also have 5. Why I do not write here 5? Because one condition is that number of elements, if you find, or जेव्हा आपण एखाद्या सेटचे नंबर ऑफ एलिमेंट्स फाइंड करतो, किंवा त्या सेटचे आपण कार्डिनॅलिटी फाइंड करतो, तेव्हा त्याच्यातील नंबर ऑफ एलिमेंट्स काउंट करतो. इफ एनी नंबर रिपीटेड मोर दॅन वन्स, then count it as once. Count it as only one. म्हणजेच काय, एखाद्या सेट मधील एक जर नंबर असेल किंवा एखादा एलिमेंट असेल, तो एकापेक्षा जास्त वेळा रिपीट झाला, एकपेक्षा जास्त वेळा रिपीट होत असेल, तर नंबर ऑफ एलिमेंट काउंट करताना त्या नंबर्स फक्त काउंट ॲज वन. व्हॉट? काउंट ॲज वन. देअरफॉर इथं 1 2 वेळा रिपीट झाला. 1 रिपीटेड हिअर ट्वाइस, बट वी कन्सिडर इट ॲज ओनली 1 एलिमेंट. Therefore these 1, then next these 2 3 and 4. Therefore number of elements in that set are 4. Number of elements of set B are 4, or cardinality of set is 4. Okay. Therefore what is the definition of number of elements of a set or cardinality of a set? Number of elements of a set is the number of distinct element in a set. The number of definition, not the number of elements of finite set. The number of elements of a finite set.